Lucy. I'm talking about geocoding and extracting locations and named entities from text. And this is the problem that I have stated. So we have text, they want to find how many locations are mentioned in this text. So can you take a guess? If you say this and that, 5. At least 5. Any other guess?
At least 7.
This and that and the other street in Porter's Lake, Nova Scotia. 7? Between 7 and 5? 6? It's 6. They actually exist, these streets. I'm not making this up. I didn't know about it until I built a tool to just look up things and came up with this. And there's other things too, like there is between city and there is this way lane and that way lane and so on and so forth. But basically to solve this problem, we have to build like a named entity recognition system that does this text, the input text, and produces this 1, 2, 3, 4, 5, 6. 3 of those locations are actually intersections because these streets intersect with each other, and the other 3 are actual streets. If you put numbers, you will get more. Street number and the street name and so on and so forth. So here is my problem, and the requirements are to identify addresses, intersections, city names for the state. I've seen some academic literature in named entity recognition, but as far as extracting locations from text, they stop at gazetteer information, like country name or city name. They don't go deeper into streets like I'm trying to do. So basically, this is the solution. I've copied this slide from another presentation because I like it. It's basically you have text, and from that text you clean it up a little bit because, let's say you have an HTML page, you don't want to get all that stuff. And then you have input strings, and you parse it with named entity recognition, you geocode it, and then collect all the results. Now, geocoding is a process that spans many fields. At least in my experience, I've been working with geocoding since 2005, 2004 when I was a grad student. And I worked at least in in one aspect or more of these fields, like linguistics, especially when you're trying to deal with various languages. Like here in Belgium, there's French and there's Flemish, and some people write them in English, so you have to make sure that you cover them all. There is data processing, which is very important. Without data, you have nothing. You have to find the data first, and you have to normalize it, fix it, clean it up, and standardize it and so on. And then there is the math stuff, the data structures that you build with that in order to access it quickly. Because when I started, there were no many fancy database plugins and whatnot to do these things for you, like MySQL Geo plugin or PostGIS. So I built this all myself. And doing so, I had to deal with all these data structures for reverse geocoding, point, and so on and so forth. Natural language processing, obviously, is the example I showed in the first slide. You have to be able to determine context and to determine which are the named entities that refer to locations in text. And the computational geometry is when you're trying to deal with polygons, like a lot of areas are defined by polygons, like when you write a neighborhood name, for example, you have to make sure that you're talking about a street in this neighborhood and not the same name street in another neighborhood, so you have to find point in polygon. Pattern recognition is when you want to be really interesting and match as many possible combinations, like when people misspell names and so on and so forth. Then of course geography, dealing with projection, artificial intelligence that I'll show later on. There will be some learning as well when you're dealing with large amounts of text, and a lot of testing. So there are many geocoders in the world that people have built over the last 10 years, I think, which is when this became popular, because before there was Google Maps, not many people bothered with this too much. I have tested a few of them, and there is the test and the data are located at this address there. What I do with the test is I take data from Foursquare, which is verified data, location data, and this sample data, a random set from Foursquare, I pass it through various geocoders, and I see how many of them are the same as the location that is marked in Foursquare. You can safely assume that somebody wrote an address and checked in a place that should be accurate data as far as Foursquare is concerned. But if you don't get the same location, maybe there's something wrong with the geocoder that dealt with that location. So Google Geocoder usually is the best of them all. There is here.com, there is Nominative, which is the worst, as far as I know. I don't know if they this is my company, Geocoder.ca, but this test is for Canada. Like for Canada, I have spent like 10 years optimizing this, so I could get pretty good results in Canada. Another company of mine is Geocoder.xyz, which is for the EU, and there I do not get such good results, and I'll go into the reasons later on. Mostly because of lack of data, but also you need a lot of optimization. And there is Mapzen, it's a recent company who came around, and these are the results. So why create a new geocoder? There is people still creating geocoders. A friend of mine just tweeted a job posting yesterday, and I retweeted it. So if you want to find out, go to my Twitter feed. So people are still hiring people to build geocoders. Because no geocoder does everything you want it to do. Let's say even Google Geocoder does not geocode parcel data. And in Canada and US, this parcel data is available as open data. So you can grab it, load it, clean it up, and do the whole process that I mentioned. It doesn't extract location data. If you copy and paste a Wikipedia paragraph in Google that contains addresses, it will not give you back the addresses. It doesn't do that kind of stuff. And so it doesn't do partial addressing, and doesn't do like address standardization. There is a big business now going around address standardization, which people wanted to clean up address data. They enter address data that is not standardized for mailing purposes, and they get the correct one. And there are the point 4 and 5, which are the most important. Nobody provides 100% coverage, and nobody provides 100% accuracy. Not even Google. And the reasons are geocoding is imprecise by definition, and usually many problems come from bad data, garbage in, garbage out. But even with good data, sometimes you have ambiguities. Like there are, for example, let's say in Toronto. I live in Canada, so Toronto is a big city now. Is gobbled other cities and has become a big metropolitan area. And you have two different streets with the same name, but in different areas of the city. So that's an ambiguity. And so on and so forth. So this is the reasons why we need to keep working on this problem and make it better. So like I say, we need data and we need good parsing algorithms. These are the key things. Other things are added later on when you want to become more fancy, and pattern recognition is for doing fuzzy match and so on and so forth. But as far as parsing, there is two kinds, fuzzing and exact. If you want to get more results, you do fuzzy matching. If you want to do just the top level results, the exact matches, then you just parse it first and you match it with the database. And you can also fill in missing location entities. For example, I say mark Brussels. I don't say Belgium, so the software has to fill in Belgium somehow. There might be a Brussels in the US, for example. There is many cities in the US have the same names as it is in Europe, but your software needs to be able to determine that and to fill in the most likely result. So I was going to give you a quick scan. How much time do I have? A quick demo. Do I have time?
Yes.
I do. Okay. Well, this was the initial example. Let's do another one. I am in Toronto, near Young and Dundas. So basically the idea is, let's say you have a Twitter feed, and you pass the Twitter feed through the process, and I wish I could squeeze it a little bit, because here you see the confidence score. So the top result is Young Street and Dundas, which is the one I was meaning to say, with confidence 1, so it's an exact match. And then you have Dundas Street, then you also have Toronto, Indiana, Toronto, Arizona, and so on and so forth. Now, you want to avoid that. If you want to avoid that, you have to be more specific. So you have to say Toronto, Ontario. Right. And then we reprocess it. And now we only have, how many results are there? Okay, we got rid of, so we only have 5 results instead of 10 or 15 that were before. So basically, if you click on it, you see where it found these things. And the end is there because it's an intersection. So the NR, the named entity recognition system, looks into these things in order to find the location. The other thing is, it's all about context, but sometimes if you say Toronto on near this thing, it will switch back to the previous mode and will go to really match, because on is a part of, see, you have some cities in the US, but if you say, because that's Ontario, it's also named as something, you can say it with an acronym, on. Now it's back to Young and Dundas, because on capital is when you refer to the province name, you just write that. So basically you can play around with this, and you can feed it various text and see what happens. That's the main idea. There is some learning going on here, so the result you get now might not be the same as the result you get half an hour later, depending what people do with it. But generally, in theory, should get better with time. So here is when I go to the data, the most important one. I mean, you can build all the great algorithms that you can, but if you don't have data, there's nothing you can do. And how many people are familiar with Openaddresses? Right, so Openaddresses is a recent phenomenon. I found out about them 6 months ago at the OpenStreetMap conference. And back then, there were only 100 million addresses in the database. Now it's over 200. They cover a lot of areas in the world. So just using these Openaddresses, I set out to build a geocoder for Europe. Because like I mentioned before, even Google Maps fails, and even in big cities. And this happened to me before. If you Google the wrong location, the first result is the wrong location of Google Maps. I also found it interesting. But this is what happened to me. I went to Barcelona, and I had an Airbnb with that address, and I put it on Google Maps, and it sent me to the wrong location. So I decided to fix it. And this is using Openaddresses, and it's an exact match. That's where I was staying. So the problem is, Openaddresses has good coverage in some areas. If you see Spain here, there is missing 2 provinces, I think Bilbao and another one I'm not familiar with. So your coverage is as good as your data. If you enter a location in those areas, you will not be able to find the response. So as far as geoparsing and geocoding and unstructured text goes, these are the 3 main steps. First, you have to extract. Then you have to disambiguate the result. And then you have to geolocate when you go to the data. And here I wanted to do another demo, which luckily enough, now I know that the internet works, because I had put some screenshots in case it didn't. So this is the same thing for the EU, and I just pulled the address from the wiki where I was supposed to go. So if you write something like this, it's Avenue Franklin Roosevelt, and you should be correct because this is from Openaddresses. I wish I could make this. So confidence score is 0.9. I don't know why. It should have been 1, but this is probabilistic. Like sometimes the model fits exactly, sometimes it doesn't. And so basically it did match that part of the sentence for this thing. In the other hand, if you add something else after it, like grote markt, right? I had lunch there. If I wrote it correctly, it should include that in the next. Now it's a little bit slow, as you might have noticed. The reason is that it is running an Amazon instance with only 1 gig of RAM and 1 CPU. That is a problem in this case. But it did come back. If you haven't, like Franklin Roosevelt still the first one, and then you have this one that it did match. Of course, there is no Brussels in that line, but the program remembers the city from the previous line or the many previous lines and finds the most likely city based on that. So if you copy and paste the Wikipedia article into this, it will use that logic to extract locations from that.
How big is your data set?
The data set, the open addresses is 200 million addresses. So I just grabbed it. I did enrich it a little bit because in many cases they lacked city names. So I used geonames to insert city names where they're missing. But mostly I use that, and I also do some calculation for intersections. It's already computed, the intersection. It's not computed on the fly, otherwise it would be even slower. So we don't want that. So yeah, going back to that, I had prepared for the eventuality that the demo would not be possible to do with the internet. So you can put other things. This is from Wikipedia. One of the most important museums in Amsterdam is located, etc., and it should extract the address from that text. Or similarly, well, as you can see there. Or if you put a Wikipedia article for Brussels, let's say, if you click on number 3 much, then it will tell you where in the text you found it, and so on and so forth. So, like I was saying, I've been doing this for a long time. In theory, it's not difficult to build a geocoder, it's just difficult to make it cover a lot of stuff. Like, to make it over 90%. Like, anybody could build an 80% geocoder, like nominate him. Few people manage it to get it over 90%, and only very few, like Google Maps, get it over 99%. So there is a lot of work that you need to do, and that kind of work is better when it's outsourced to many people. Like I've been doing this all myself, but you can get this server and do it too if you have the time. There is a lot of cleanup going. You need to do on Openaddresses. Unfortunately, they have a lot of bugs. Sometimes they're missing city names. Sometimes the street name even is missing or is gobbled up. And there is some problems with character sets, UTF-8 or non-UTF-8. Sometimes you find some strange things. So if you want to embark on this project, be my guest. So that's where you come in. I hope that this talk will have inspired some of you to go on and work on this problem. The source code and the data is in that URL. I don't know if you noticed there is a link there that says get this server. Did I? Oh, maybe I didn't. So basically, oh, it's here. So click on that, and then you can get the server or Amazon Cloud. And a micro instance with only 1 gig of RAM and 1 CPU is free on Amazon. So I'm running all this for free. This is the other bonus. You can get a free server, why not? And yeah, and just I have a Twitter handle. I check once a day or once every 2 days, and an email address. You can email me, let me know. In case you're wondering, I wrote this all in Perl. By the way, it's 47,000 lines of Perl code.
Is it on CPAP?
No, it's not on CPAP. The only problem with that is that there is a lot of stuff I could get rid that now I don't need to do myself. There is a lot of stuff that's done in the database, or it's done by third-party utilities. But when I started, they didn't exist, so they're there and they still work. That's all I have. Thanks.